So on our number 5, we had this function here, and they wanted us to find the equation of the tangent line to the function at this given point. And so first we have to find the derivative. So I would probably put it in terms of u first and say this is just e to the u, where u is x to the 7th. So the derivative of e to the u in this section they talk about would just be e to the u times the derivative of u. Again, sorry, sometimes my d's look like 8. So doing substitution, e to the u is e raised to the x to the 7th, and if I multiply it by the derivative of u, well, that would just be 7x. So here is my derivative, my slope generating function. If I want to find out what the slope is at 1, I just plug 1 into my slope generating function. So I get e to the first power times 7. So I get 7e. So this is my slope. And now using point slope form, I have y minus my y1 equals my slope times x minus my x1. And there's my x1. And I think if we just move e to the other side by adding e, we get the answer that they had with the homework. So nothing new except for understanding how to find the derivative of a e to the x type function. The next one I want to look at was number 6. And so just reminding us how to do this implicit differentiation. And so equation looks something like this. So this one is easy. That's 2x minus 2y dy dx. And on the right hand side we get 0, but finding the derivative of that one. So that's like e to the u. Well, the derivative of e to the u is e to the u. Again, looking at finding the derivative of this thing. So I change it to e to the u. The derivative is e to the u times the derivative of u. So that would be e to the xy times the derivative of xy. So that we'd have to use the product rule. So we have the derivative of the first times the second plus the first times the derivative of the second. So that's my dy dx. So that's what I would put in up here. I end up with a y plus x times dy dx. And just like in the past, what we would do next is try to isolate our dy dx's. So expand this, get all your dy dx's on one side, and then solve for dy dx.